Hey, we're looking at related rate problems. We've got, this happens to be a right circular cone. So we're looking at the radius r of a cone and it's increasing at a rate of 12 meters per second. The cone's radius is 3 times the height. So I know, Rod, boy, I can remember when I was learning this stuff for the first time. That just blew my mind right there. Anyway, I'll try to hopefully clear that up. But anyway, it says, what is the rate of change of the volume when R is equal to 10 meters? So the rate of change of volume, so we're looking at dV over dt. That's what we want to find. And then, of course, we've got another problem here, but we're going to look at that here in just a minute. I'm not going to read that. So anyway, so we're wanting to find dV over dt. We're given R, which is 10, and we're given dr over dt, which is 12 meters per second. So let's go find dV over dt. Well, we're going to need to know the formula for finding the volume of a right circular cone, and this happens to be it right here. Pi r squared times h over 3. I guess I should have a picture of a cone, but I think everybody should know what a cone looks like, right? It's got the height and the radius there at the bottom. But anyway, now they gave us a relationship. They said that the radius was 3 times the height. So what you need to do is you need to write this out. The radius is, and is equals here, 3 times the height. And then what we're going to do is we're going to go ahead and get this thing all in terms of r. Right? So we're going to replace this h and get everything in terms of r here. And so we go ahead and solve for h in this problem. So h is equal to r over 3. And then we take this r over 3 and plug it into the r right here, as you can see. All right. And then, of course, we need to simplify this down as much as we can. We have r squared times r, which is r cubed. So I have 1/3. Take that down into the bottom, and there it is. We have pi r cubed over 9. So now what we're going to do is we're going to take the derivative. So we got dV over dt is equal to, bring the 3 out front, pi r squared over 9 times, remember we tack on a dr over dt because that's what we're taking the derivative of. And then, of course, we want to simplify this down as much as we can. We end up with pi r squared over 3 times the dr over dt. And then what we're going to do is just go ahead and plug everything in that they give us, right? So they gave us r, which was 10, and the dr over dt, which was 12. And then we need to simplify that down. And we end up with dV over dt is 400 pi m cubic meters per second. Okay, well, we went ahead and took care of this first problem here. Now we're going to work on the second one. So we got to find the rate of change of the height. So that's going to be dH over dt when the rate of change of the volume, which is dV over dt, is 10 cubic meters per second. And it says the volume is equal to 2 cubic meters. So we're looking for the height. That's dH over dt. Alright, well, let's take a look at it. Oh, wait a minute. There's something else I need to mention here. The cone's height is twice the radius. The cone's height is twice the radius, so we need to remember that. Alright. Okay, we start with that formula again for finding the volume. And we got pi r squared h over 3. And the height was twice the radius. So we go ahead and write that out. And now this time what we're going to do is we're going to solve for r in this problem. And we have h over 2. H over 2. And so we go ahead and take the derivative of this. We get, well, I guess actually not yet. Hold on. So we got dV over dt. I guess I go ahead and rewrite this stuff down here. It's 10 cubic meters per second. The volume, okay. And of course dH over dt is what we're looking for. Alright, so we go ahead and take that r, which was h over 2, and we plug it in right here so we get everything in terms of h. And so that's going to be h squared times h is h cubed, And of course you square the 2, you get 4. And then we're going to drop that 4 down into the bottom, so we end up getting 12. So there's the simplified version right here that we need to work with. Okay, now we're going to take the derivative of this. So we got the derivative of v as dv over dt is equal to, take the 3, bring it out front. We have 3 pi h squared dh. Alright, sorry about that. Just a microphone. Then of course we tack on the dh over dt outside. Simplify this stuff down. 3 goes into 12 4 times. So we got pi h squared over 4 dh over dt. Alright, and now what we're going to do is plug in everything that they gave us. So remember, we're trying to solve for dh over dt here. They gave us dv over dt, but we didn't get h. But remember that the volume, which was pi h cubed over 12, right? So the volume is 2, and so we set this 2 equal to, right, what the volume is equal to there, and then solve for h in this problem. And so we want to take this 12, bring it up, and then divide by pi, and then raise both sides to the 1/3 power, and that's what I've got going on right here. Alright, so now that we know what h is, we're going to go ahead and take this h, which is all this stuff right here, and plug it in, right, remember, to our formula up there. And now what we need to do is simplify this down as much as we can, and we want to go ahead now and solve for dh over dt. Now remember what this was right here. This was dv over dt, which happens to be 10. Okay, so a bunch of algebra going on here. Let's work it out. Alright, so I don't know what's going on here. Oh, I multiply the 1/3 times the 2. That gives me the 2/3. But also in parentheses, here's this 2, and if it's squared, that gives us 4. Okay, and of course we cancel the 4's out if we want. Of course, that's what we're going to want to do. And that's what I do here. And then it looks like I'm going to break this up as the 3 raised to the 2/3, pi to the 2/3. I can take this pi to the 2/3 up to the top. We end up with pi to the 1/3, and then we're solving still for dh over dt, and we end up with our final answer. Don't forget your units, meters per second.